Welcome to Accelerated Math 106, Module 1.8, Test for Divisibility. So, the idea of a divisibility is talking about if a number can be divided by another number so that the remainder is zero, then we say the number is divisible by the divisor or the divisor divides the dividend evenly. Okay, divided by the divisor divides the dividend evenly. So basically, we want to learn the divisibility by 2, 3, 4, 5, 6, 9, and 10. Learning divisibility also actually it helps tremendously when it comes to simplifying fractions in module 2. All right, so I'm gonna go through these rules for divisibilities, and then we'll do some examples. So a lot of these rules for divisibility really, if you really look at it, 2, 3, 4, 5, 6, 9, 10, all these are on the multiplication table 1 through 10 that we're talking about in 1.3. So learning your multiplication table is very important. So in addition to multiplication table, we can also learn a couple of rules about divisibility. It help us out with dealing with bigger numbers. Okay, numbers that they are not on the multiplication table. Excuse me. So when it comes to simplifying fractions, when you run into a number that you don't recognize that's not on the multiplication table, using divisibility can actually help you to know how to simplify those fractions. So a number is always divisible by 2 if the ones digit, if the ones position ends in, or some people say if the number ends in 0, 2, 4, 6, or 8. All right. A number is divisible by 3 if the sum of the digits is divisible by 3. So this one's kind of weird. Let me show you. For a quick example, the number 111. Can 3 go into 111? So you can kind of figure this out before you write out the long division. A number is divisible by 3 if the sum of the digits is divisible by 3. So all you do is take individual digits of 111 and add them up. 1 plus 1 plus 1 is 3. So 3 can go into 3. That means 3 can go into 111. Okay, that's how we actually check for the divisibility by 3. By simply add up its digits and see if 3 can go into it, to the sum. If 3 can go into the sum of the digits, then 3 can go into this number. A number is divisible by 4 if the number formed by the last two digits is divisible by 4. So divisibility by 4 is looking at the last two digits. Make sure 4 can go into the last two digits. 0, 0 is considered to be divisible by 4 because if a number ends in 0, 0, that means that's 100. 4 can always go into 100. All right, a number divisible by 5 if the ones digits or the ones place value is 0 over 5. Most of us know that. All right, a number is divisible by 6 if it can be divisible by both 2 and 3. Okay, 2 and 3. Because if 2 can go into it and 3 can go into it, that means 6 can go into it. Where does the 6 come from? 2 times 3 is 6. Divisibility by 9 is the same as divisibility by 3. If the sum of the digits is divisible by 9, then 9 can go into that number. All right, divisibility by 10, where the number got to end in zeros. All right, so it's just kind of quick. You have these rules on your handouts. So use your handouts. Let's take a look at some of these examples. Okay, So this problem says use the test for divisibility to determine which number divides evenly into the given number. So what you don't want to do is take every one of these and then divide it into 207. What you want to do is actually use the rules for divisibility. So let's just start out one at a time. Can 2 go into 207? The answer is no, because divisibility by 2 says the ending digits, the last digit or the ones place value got to be 0, 2, 4, 6, or 8. So that's not. All right, can 3 go into it? Well, in order for 3 or 9 to go into it, that means I got to add out the sum. I got to add up its digits and see what the sum of the digits are. So 2 plus 0 plus 7 is equal to 9. So 3 can go into 9. That means 3 can go into 207. So 3 is it. Well, divisibility by 9 is the same thing as the 3. If 9 can go into 9, that means if 9 can go into the sum of its digits, then 9 can go into 207. Check. All right, 4. Last two digits got to be divisible by 4. Can 4 go into this last two digit, which is 7? No. 5. 5 can only go into number ends, the ones position. The ones place value got to be 0 or 5, which is not, so no. 6 is a no, because in order for 6 to go into 207, it got to be both 2 and 3. All right, 10. 10 is a no, because 10 can only go into numbers ends in 0. So 3 and 9 is the only answer that you check. All right, let's try a bigger number, okay? 86,058. So basically, just by thinking about the rules for divisibility of 3 and 9, you know we need to add up the digits. So let's go ahead and do that, okay? Let's go ahead and add up the digits. 8 plus 6 plus 5 plus 8. All right, this is 8 plus 6 is 14. 14 plus 5 is 19. 19 plus 8. 19 plus 8, 27. Awesome, awesome, awesome. I know by divisibility by 3, if 3 can go into the sum of its digits, that means 3 can go into this big old number. Check. All right, if 9 can go into sum of its digits, which is 27, 9 does go into 27 3 times. That means 9 can go into this big old number. Check. All right, 2. 2 can always go into number ends in 0, 2, 4, 6, or 8, which is 8 right here. So check. If 2 and 3 can go into this big old number, that means 6 can go into it. Check. All right, try 4. 4 is looking, divisibility by 4 is looking at the last two digits, so we got to give it a try, okay? Can 4 go into 58? Well, 4 go into 5 one time already, so that's 18. 4 does not go into 18 evenly, so no. 5. 5 can only go into numbers ending zeros or 5, so that's a no. 10 can only go into numbers ending 0, so that's a no. So that's 2, 3, 6, 9. Can go into that. All right, let's try one more, okay? One more time. When I do these problems, I always add up its digits first, just to see if 2 and 9 can go into it. 1 plus 6 plus 6 plus 2 plus 9 plus 4. I know 1 plus 9 is 10. 10 plus 6 is 16. 16 plus 6 and 6 is 12. So that's 28. Uh-oh. 3 cannot go into 28. 9 cannot go into 28. So 3 and 9 is out. All right, 2. 2 can always go into numbers ending 4. All right. So 3 is out. 4. 4 is checking the last two digits, so let's give it a try, okay? 4 going to 94. Let's see how many times. 4 going to 9 one time. Excuse me, 2 times. So that's an 8. Subtract is 1. Bring down the 4. 4 does not go into 14 evenly, so 4 is out. 5 can only go into numbers ends in 0 or 5, so that's a no. 6 is a no, because 6 can only go into this big number if both 2 and 3 can. We already said 9 is out, 10 is out, so this one, only 2 will work. All right. Now, let's do it slightly different. Determine a set of 2 numbers that are divisible by 9. So this one's a little bit more work. We got to quickly add this up. So 9 can only go into numbers that the sum of its digits is divisible by 9. So we got to add up all these digits first, okay, real quick, to see if 9 can go into them. So this is 3 plus 3 is 6, 6 plus 4. 6 plus 4, 10. 10 plus 8 is 18. So this sum is 18. So 9 can go into 18. So that means 9 can go into this big old number. All right, this is 5 plus 7 is 12. Nope. This is 17. All right, this one up here. 10 plus 2 is 12. Nope. 16 plus 9. What's 16 plus 9? 25. Nope. All right, 16 plus 6. 16 plus 6 is 22. Nope. 9 cannot go to 22, right? This is 4, so that's a no. 8 times 3 is 24. 24 plus 3 is 27, so that's it right there. 9 going to 27 3 times, so 9 can go into this big old number. All right, 7 plus 8. 7 plus 8, 15. So 2 numbers. Hold on a minute now. This is possible. 8 times 3, 24, right? Did I do this one right? That's 18. Okay. I thought it's only going to be 2 numbers. Maybe it's 3. All right. 24 plus 3, 27. 9 can go to 27. Hold on. 7 plus 8 is 15. 15 plus 3 is 18. 9 can go into 18, so 9 can go into this one too. So I thought it was going to be 2. I guess I can check all 3 of them. All right. Oh, this one is interesting. Got to be both 6 and 5. 6 and 5. 6 and 5. All right. Easiest way to do this, when you have a 5 or a 10, you always check the last digit first. Because remember now, 6 is divisible. Divisibility by 6 says it got to be 2 and 3, right? But 5 is unique. 5 can only go into number ends in 5 or 0. So far I got 85, 30, 150, and 60. Now I just need to see if 2 and 3 can both go into it. I know 2 cannot go into 85 because it does not end in 0, 2, 4, 6, or 8. So that's out. All right. I know 2 can go into 30. I know 3 can go into 30. So that's a check. 60. I know 2 can go into 60 evenly, right? Because it ends in 0. I know 3 can go into 60. So there you go. Check. All right. 150. If I know 2 can go into 150 because it ends in 0. Can 3 go into 150? If I add up the digit, 1 plus 5 is only a 6. So, ooh, 6. So 3 can go into it too. So if 2 can, 3 can, 6 can. So these are the 3 numbers. I'm still trying to figure out, determine a set of 2 numbers. I must did something wrong. This is 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 8 is 18. Yeah, that's right. That is 7 plus 8. 7 plus 8 is 15. 15 plus 3 is 18. So this one is weird. This is 3 of them. I wonder why they say 2. All right. Ugh, this one nasty. 9 and 4. Ugh. Oh, this one not cool. All right, divisible by both 9 and 4. So check the last two numbers. For 4, check the last two numbers. All right, let's see. 83. No. And this is where knowing multiplication table does help. 4 times what number? Where the answer ends with a 3. If you really think about it, 4 times what ends with a 3? Nobody. Okay? 4 times nobody ends with a 5. All right, 72. 4 times 3 is 12. Ends with a 2. So that's worth a try to see if 4 can go into it. Can 4 go into that last two digits? 72. 1 time 3, bring down the 2, that's 18. So yes, that one is a yes. Let me erase these two. All right, 84. Definitely. 4 going to 8 2 times, 4 going to 4 1 time. 87. No. 4 times nobody ends with a 7. This is 72 again, just like that one. So good. No 5. 52. Ooh. 52, what to try? Because 4 times 3 ends with a 2. So 4 going to 5. 1 time. That's 13 times. So that's good. 4 times nobody ends with a 3. So I got 4 choices here. Now I just need to add up its digit, make sure 9 can go into it. So I'm going to start right here. All right, 2, 2, 2 is 6. 6 plus 5 plus 7, that's 12 plus 6, which is 18. All right, 9 can go into 18. 4 can go into this last two digits, so that's a check. Let's see, this is 10. That's 10 plus 17. 9 plus 8 is 17. So 10 plus 17 is 27. 27 plus 4 is 31. 9 cannot go to 31, so that's a no. All right, this one, 18 plus 9. 18 plus 9 is 27, so that's a yes. 9 can go to 27. 9 can go to that big old number. All right, this is 2 is 4. 4 plus 5 is 9. 9 plus 9 is 18. 9 can go to 18. 9 can go to this big old number. So these 3 are the one you check. All right. So hopefully by going through these examples, it helps you to learn the divisibility. So divisibilities, the rule for divisibility does not go away. We use it quite often in Module 2. All right. That concludes this lecture video. Thank you for watching.